Morning, my name is Naveen Koriakose. I have recently graduated from British University and I am working as a senior commissioning engineer for Alpin Limited in Masala City. Today, we will be discussing about cost-benefit analysis of continuous building commissioning. Building commissioning may be a new topic for at least some of you, or continuous commissioning may be a new topic. So we will discuss building commissioning in general and continuous commissioning in depth. In continuous commissioning, there are 5 different steps, including building information collection, benchmarking, data analysis, fault detection and diagnosis, energy saving measures implementation, and actual saving calculation. And then we will discuss a case study where building continuous commissioning is employed. This case study building is in Jeddah. Commissioning is defined as a quality-oriented process to meet the owner's project requirements. Commissioning ideally starts from pre-design to building design, then during construction and to the occupancy phase. Occupancy phase commissioning is generally known as existing building commissioning or recommissioning. But continuous commissioning or monitoring based commissioning goes one further step. We will explain it later. Commissioning is a new topic in the Middle East, but in the United States and in Europe it got a wide acceptance. Mr. Ivan Mills from the United States, Lawrence Berkeley's National Laboratory, he had done an extensive research on commissioning on about more than 650 buildings. And in his book published in 2012, he says that commissioning is the single most cost-effective strategy for reducing energy, cost, and greenhouse gas emission. And his research reveals that from commissioning, median benefit cost ratio of 4.5 and cash on cash return of 91% can be achieved. We will discuss these terms later. Primary purpose of commissioning is to identify issues during design, construction and occupancy. So, generally, these are the outcomes from commissioning. Simultaneous heating and cooling can be identified. Inefficient thermal distribution, air conditioning distribution can be identified. Calibration issues on sensors can be identified. Oversized equipments can be identified. So all these issues have major contribution towards monitoring or money, but still commissioning is not being employed in our buildings in the Middle East. Even we have a lot of we can achieve a lot of savings from commissioning. Why commissioning is not employed in our buildings? The ultimate answer is uncertainties about the cost and benefits of commissioning is the key barrier in employing commissioning in our buildings. Because in this area there is no major research on the benefits of commissioning is done. So I really recommend a cost-benefit analysis research on continuous commissioning so that we can learn what are the benefits or we can calculate actual savings. When we consider commissioning, we cannot really calculate cost savings because during commissioning we will find issues in design and it will be resolved. So with commissioning we actually call it avoided cost. We will calculate the avoided cost. Avoided cost is this money that would have spent if there is an issue that was not identified. Once that issue is identified and cost is saved, we can say it has avoided cost. As I said, there is a difference between recommissioning and continuous commissioning. In recommissioning, building will be commissioned at specified time as a one-time effort. Maybe after first year of handing over, or maybe after 2 years of handing over. But continuous commissioning is a continuous process. Monitoring based commissioning will be done continuously. These are the 5 steps involved in monitoring based continuous commissioning. First step is building information collection and then benchmarking. Third step is fault detection and diagnostic, energy saving measures implementation and asset savings calculation. When we consider buildings in Middle East, step 2 and 3 are serious issues. Like benchmarking is a serious issue, and fault detection and diagnostic is like a Herculean task. We will discuss it. We will be focusing more on these 2 points. This is the process flow diagram. This explains the concept more. Diagram 1, block 1. It shows step 1 name, continuous commissioning. For continuous commissioning, we need buildings information. In block diagram 1, building information will be collected. We will install electrical and water sub-meters in buildings through which we can collect building consumptions. Research says that more than 40% of energy consumption annually is by the buildings. And HVAC, lighting, swimming pool, and plumbing system are the major energy consuming services in the building. Block diagram 2. This represents steps 2 and 3. Benchmarking and data analysis. Information collected from the building will be compared against a benchmark. There are different benchmarking systems, like there's a tool from Environmental Protection Agency, US Environmental Protection Agency, Energy Portfolio Manager. You can use this tool to compare your building's information. And you can analyze it using an automated continuous commissioning application. This analyzed data will help the commissioning service provider to come up with solutions to improve the building's performance. This is the 4th step. In the 5th step, actual calculations from commissioning will be performed, and then again the cycle repeats. Benefit from the recommissioning is this is continuous, and if there is any issue in the building, the commissioning service provider will know it immediately. In real time, he can access the ACC app even remotely, and he can suggest performance improvement measures. So there will not be any loss in energy. Information collection. We know lead estimama or ANSOFA gives importance to energy measurement or sub-metering. In our buildings, we use more than 40% of annual energy, and another important issue in our buildings are excess water usage. We can control our consumptions only if we know the amount we consume. So sub-meters must be installed in the building, and not only that, sub-meters must be connected to a central monitoring station where data can be processed. For continuous commissioning process, data must be collected in short intervals from HVAC, swimming pool, or any other major energy consumer. So there's a huge amount of data. This must be processed logically. And second step is benchmarking. Here. So we need to analyze or compare our data against the benchmarks. We can use Energy Portfolio Manager. Ultimately, benchmarking depends on climatic conditions, social and cultural conditions of the region. If we use energy portfolio manager, it is built for US. Comparing a building in the United Arab Emirates against a building in US is like comparing apples against oranges. So we need a public benchmarking tool for the Middle East. And when we consider the benchmarking tool should get input from a lot of buildings so that it can make a benchmark. So there's a lot of data collection, data handling and processing. This is a screenshot of Energy Portfolio Manager. In Energy Portfolio Manager, it provides a score based on score on a scale of 1 to 100 based on your building's energy consumptions. Data analysis is the next step to detect the faults. Automated continuous commissioning tool can automatically detect the faults in the building. I have developed a demo application. This can further be developed maybe during the research. It can link to an automated continuous commissioning application where you can select buildings, registered buildings, and you will directly know the issues in systems. And you can benchmark, like you will get score of your building based on national benchmark, energy benchmark. You can input data, you can select building type, phase of construction. So this can be used as a benchmarking tool. This can be further developed as a national benchmarking tool. In this benchmarking continuous commissioning application, buildings design intent will be changed. We know that most of our buildings will not perform as it is designed because operators or owners think that building design, energy design intents are set just for the approval of design. It can never be achieved. That's the mindset. But with this tool, we can actually change the design energy goals. Automated commissioning tool, it can perform building analysis, it can give you suggestions for improvement from building level to component level. As far as buildings in Middle East is concerned, we can give primary importance to energy, water and indoor environmental quality performances of the building. With this application, the service provider can remotely access this online application and he can suggest recommendations. If required, he can come on site and perform tests to find actual issues in the building. From similar researches, it proves that these issues can be solved. If you do more detailed region-specific research, we can find more improvement opportunities. Now this is the fifth step, actual savings calculation. ACC application can be further developed to calculate the avoided costs in terms of simple payback time. This is the project cost divided by the first year cost saving. You can calculate based on benefit cost ratio. This is the term we discussed before. This is sum of project benefits over the assumed measured lifetime divided by the project cost. or we can calculate it based on cash return or cost of avoided carbon. This is a case study. We perform continuous commissioning in a warehouse building in Jeddah. This is the energy portfolio manager screenshot. Commissioning was done in 2014. In 2013, this was the score 70, and after commissioning 77. So there is an improvement of 12% in energy cost. So through commissioning, we can benefit, we can save money, we can save or we can reduce carbon emission. Thank you.